Well, hello everyone. Long time no speak to. Rich here from RBBA on another survey. Today we've been called out to a property where a mortgage has been applied for in a particular property, and the mortgage surveyor has come out and he's declined the mortgage, basically saying that the property has got rise and damp. Now, the report I've actually received is based on one test only by our trusty moisture meter, and he is basically stating that throughout the entire ground floor of the property it's reading 99% moisture content on the walls. Now 99% is actually just short of saturation, and if I was seeing that, I'd be certainly asking a few questions, because we really should be seeing running water at 99%. He has based it on one test only, which is from the moisture meter. Now these things, for you, those that don't know, they are calibrated to take moisture readings of timber only. Okay, timber only. So skirting boards, door frames, window frames, etc. As long as they're timber, they're very, very accurate. If they're being used on plaster, wall plaster, etc., it's a guide only. Okay, the reason behind that is softwoods are all relatively similar in composition, whereas wall plasters have got hundreds of different mixes. Same with bricks, hundreds of different mixes. All that type of material, there's just no uniformity across the board. So they are calibrated to suit timber and timber only. Okay, so what we're going to do here today is we're going to go around first of all and read the moisture readings out that we're seeing, and then I'm going to prove that what this guy is actually detecting is actually salts on the wall. Okay, now I've had a look at this property, and yes, there is some damage to the walls, but it's not running water. It's certainly not enough for me to say you've got a rise and damp issue. I'll show you a photo. I'll show you a picture of it now in just a second. But we're going to go around first of all with the protometer, and I'm going to show you the levels that he's reading, and he's actually denying a customer a house purchase based on this and this alone. Now there's a minimum of 3-4 tests that should be carried out to diagnose rise and damp issues. This has not been carried out in this situation because some of them are destructive, and there's not one sign of any destructive testing on these walls. So keep in touch. So what we're doing here now is we're going to use the moisture meter to go along, and we'll take some surface readings. I don't know how well this will come out, but you can see there's a bit of dampness there. Definitely no argument, dampness. Okay, so remember 99% is what he's quoting. 10%. 21% moisture content. Even if I put it on the heart of this, yeah, it rises up 100%, no problem. So in effect, if we were relying on this moisture meter alone, that's saturated. Okay, can't take any more. It's 100%. Okay, but as we move along here, 20%, 15. Okay, so you don't see any running water there. This is what has been diagnosed as rise and damp. Okay, so what we're going to do now is we're going to actually drill into the structure itself. If rise and damp is coming up through the brickwork, the wall itself on the inside the structure should actually be soaking as well. Now, if it's not soaking, it's just basically forming on the surface, or it's actually salts, because this is not actually differentiating between moisture and any other conductivity. It's not detecting moisture at all. It's just seeing how much resistance there is between the two probes up here at the top. Okay, but salt that's in the wall will also give you a reading of high moisture content as well. So we're going to take a reading actually inside the wall, and if that's wet as well, we then do another test. So stay in touch. So we've now drilled into the wall. You can see my little probes here. Okay, so they're just acting exactly the same way as
those little pins on the front of my moisture meter, and as they go in, you can see that it's shooting up to 100% yet again. Now the problem is here again, that's showing saturation. There's no running water here. Okay, so we then have to question, is this actually damp, or is it just the electrical charge is actually being conducted by another material like salt? So what we're going to do now is we're going to actually take some dust samples and test it for chlorides and nitrates. So basically if there is water rising up the wall, that drags with it all sorts of contaminants that's in the ground, your chlorides, your nitrates, etc. But also, more importantly, we're going to use the only test that's actually on the market to categorically prove if something is wet or not, and that's called the calcium carbide test. Calcium and carbide together mixed with water actually produces an acetylene gas. Okay, but you need all three. So you need your calcium, you need your carbide, and you need good old-fashioned H2O. If you don't have H2O, you're not going to produce acetylene gas, you'll just produce calcium carbide. We can then measure that to categorically state this is moisture that's in the wall. Basically at the minute it is actually saying that there's something in that wall there that's conducting moisture, but as I say, there's not a drop of water there, and actually the dust you see on the floor here, that's as dry as snuff. Okay, so we're going to take some salts, some dust here from within the wall, analyze it for chlorides and nitrates, and that should determine whether that is actually rising damp or not. So this is the actual dust that we've taken from the wall. Again, you can see there it's not running with moisture, it's not 100% saturation. There's the hole, some more dust. So we're going to analyze this dust here now for, as I say, chlorides and nitrates. Then we're going to actually test the how much moisture is actually in it. You're always going to get moisture in a wall. It's whether or not it's an acceptable level or not. We're going to use this piece of kit here, which is where we will measure acetylene gas inside the chamber. There is other videos of me doing this online, so have a look at them. And then we're going to actually test using good old-fashioned deionized water in little test tubes. We're going to test for chlorides and nitrates. Come back in a minute with the result. So we now have two samples. We've split them up because what we're going to do is test for we're going to test for chlorides on one and nitrates on the other. So it's two little tests. We've got our two little canisters there all filled up, all well mixed through, and then we're going to add in some of our wee tablets. These will change colour then, and depending on what colour they change, that'll tell us if there's any chlorides or nitrates in it. If there is chlorides and nitrates in it, it gives us a fair indication that it is rising damp. So we're going to do that next, and then we will put the rest of the dust that we've collected into the calcium carbide reader and just determine whether it is actually moisture that's in the wall or not. So we've got our little samples here. This one's actually testing for nitrate. If that goes brown or red, it means there is a confirmation that there is a nitrate in the actual wall. If it goes yellow, no nitrates. Okay, so no water soaking up the wall that contains nitrates. This is actually a very interesting one here. This is for chlorides. Okay, and you see the colour that's gone. Now, if that was brown, that's conclusive that there's no chlorides present. If it is yellow, it means there is chlorides present. Okay, so brown, no chloride, yellow, chloride. Okay, but you can see there it's a green colour. Okay, so maybe bordering on yellow. So it has taken something of chloride. What has actually happened there is the glasses have been washed out with just normal tap water. So we're going to do that test again and use the deionized water just to clear that out first of all and see what the result is then. This is more interesting. This is your speedometer, calcium carbide. Calcium carbide plus H2O creates acetylene gas. And in this case, we've added all the mixture together and it's produced a 1% reading. Now the BRE, the British Research basically say anything under 5% is not deemed to be damp. So this is well under damp, well under the 5%, it's only 1% there, so there's no moisture in that wall, so we can categorically say it's not rising damp at this property. And that what this guy, and what we're actually reading as well, because remember we detected 100% moisture content, but it was taken on a plaster wall, which you cannot use a moisture meter, despite what people think, for testing of wall plaster. What it's actually reading 100% is that there's 100% conductivity with the prongs at the moisture meter, so it's not rising damp at the property. It is probably just salts, that hygroscopic salts that have been absorbed into the atmosphere, or absorbed from the atmosphere, causing little salt bubbles, which is exactly what we see.
So there you have it. We categorically basically ruled this guy's survey out as being null and void. There's no rising damp in that wall. There's no dampness worth talking about in that wall. One final little test that we're going to use is using our very trusty thermal imager. Great piece of kit. The theory behind this is when something gets wet, it transfers temperature quicker. A bit like you stepping out of the shower, you automatically get colder very quick because moisture conducts heat very quickly. So with the thermal imager, if this was rising damp, we would see an area of dampness, a darker area with the camera, and that's just basically moisture relieving the wall of its heat quicker than the rest of the wall. So it is just one final nail in the coffin, but it's worthwhile using it just to dispel any potential rising damp issues.
So here's the camera here, and we're down along the ground, and you can see that wall there is all a very nice constant color, with the exception of the radiator. There's no, you see the temperature right up the top left hand corner there, so we're doing 21.9, 22 in and around that mark, but as we raise up the wall it's still staying around the same temperature. Same over in this corner. If we go down just above skeleton, 21, 22, 21, it's not a damp problem. There's no dampness on that wall. It's not getting rid of heat quicker than any other part of the wall. It's a nice similar color throughout.